Hello everyone, today we're gonna go through the homework 2 solutions. So first problem is 2.47. It's describing a water column in a glass tube is used to measure the pressure in a pipe. The pipe is half inch in diameter, and it asks how much of the water column is due to the surface tension effect, and also asking us about different size of other pipe tube. So for this problem is actually asking if we have a pipe here and it's connecting to a water column. So tube here, and the water actually is coming this way because of the water velocity in the tube. Our water in the column will rise to a certain height, and because of the surface tension, it actually will rise a little bit more here. That's our delta H. So the reason we need to consider this kind of effect is because when we trying to figure out the pressure in the tube, this water column change will actually influence our readings. So we need to kind of remove it from the actual reading. So to find the surface tension, we're gonna use the equation 2.23 in textbook. It's this equation, delta H equals to 4 times sigma over gamma times D. Okay, so for the gamma, we can use figure 2.18. We're gonna assume the temperature is at 20 degrees Celsius, and it gives us a sigma of 0.0728 Newton per meter. So, but our problem is in English unit, so we need to convert the sigma to English unit. So sigma equals to 0.0728 Newton times 0.2248 Newton per pound force over 1 meter times 3.2808 feet per meter, and it will give us a number about 0.05 pound force over feet. Okay, so we have a sigma. The delta H is now writing as 4 times 0.04 pound force over feet. The gamma of water is 62.4 pound force over feet cube times D. And we have 3 different D's. The first one, D1 is equals to 0.5 inch, which is 1 1/24 feet. D2 is equals to 1/8 inch, which is equals to 1/96 feet, and D3 is 1/16 inch, which gives us 1/192 feet. Okay, so our delta H1 will be equals to 4 times 0.05 over 62.4 times, which gives us 0.00769 feet, which is 0.0923 inch. And for delta H2, it equals to 4 times 0.05 over 62.4 times 1/96, which gives us 0.00708 feet, which is 0.369 inch, and our delta H3 equals to 4 times 0.05 over 22.4 times 1/192, which gives us 0.0615 feet, equals to 0.739 inch. Now let's look at the second problem. So we have a hydraulic machine here, and in the left we have a mouse with mass M1, and on the right we have an elephant with mass of M2. So part A, we are going to derive an equation for this kind of a situation. So here we have the assumption that it's frictionless for the pistons, and it's also massless for the pistons. So here we only need to consider for the pressure, P1 is equals to P2. Okay, so, and the pressure is equals to the weight divided by the area. So for P1, we will have V1 over area 1, so it gives us W1 times pi times D1 squared times 1/4. So we will have 4 times W1 over pi D1 squared. For P2, we will do the similar things. Two over 1 pi D2 gives us 4 W2 pi D2 squared. And because of P1 equals to P2, we will have 4 W1 pi d1 squared equals to 4 W2 pi d2 squared, which we can simplify this to W2 over W1 equals to D2 squared over D1 squared. So now in the problem B, we are asking to find determine a set of value D1 and D2 that a mass of 25 gram mouse can lift a 7,500 kilogram elephant. So we'll use the equation from part A, W2 over W1 equals to 7,500 kilograms times 9.81 over 0.025 kilogram times 1, which equals to 300,000, which is your D2 squared over D1 squared ratio. So if we assume D1 equals to, for example, 70 millimeter, then your D2 will be 300,000 times 0.07 meter squared. Square root of that gives you 38.3 meter. For problem 3.16, we have a tank with oil, water, and air inside of it. So the first part of the problem is asking what is the specific gravity of the oil, and the second half of the problem is asking the pressure rating on gauge 3. So first we write down the pressure equation, the balloon equation. PB here will equals to PA plus gamma of the oil times height of the oil. So the reading on the point B is 58.5 kilonewton per meter cubed. Equals to the pressure at PA is 50.0 kilonewton per meter cubed. You can also call it kappa as well, plus gamma of the oil times the height, which is 1 meter. here you can easily find that the gamma of the oil is equals to 8.5 kilonewton cubic meter. Okay, so convert it to SI unit, will be 8,500 Newton per meter cubic. So your specific gravity of oil is the gamma of oil over the gamma of water, which is 8,500 meter per meter cubed over 9,810 Newton per cubic meter, which is 0.87. For part C, we're asking to find the reading at point C. So the pressure at point C is equal to the pressure at point B plus the 0.5 meter of oil and 1 meter of water here. So times the gamma of the oil, height of the oil, plus gamma of the water, times the height of the water. The pressure at point B is given here. Plus cube times 0.5 meter plus 0 meter cubed times 1 meter. Okay, so it gives us 72,600 Pascal equals to 2.6 kPa. For point 3.18, we have two pistons, one with smaller diameter of 4 centimeters with 390 Newton here, and we are asking to find F2 with a diameter of 10 centimeters. And here we're gonna neglect the weight of the pistons. So for this kind of problem, we're gonna first find what is the pressure at the piston on the left. So P1 equals to F1 over A1. F1 is given, which is 390 Newton, and area of A is 1/4 pi times the diameter of the piston, and we're gonna convert it to SI unit, 0.04 meter squared. Okay, so this will gives us 310,342 Pa. Now we're gonna find the force at P2, but first we're gonna find the pressure at point 2. So P2 plus gamma Z2 equals to P1 plus gamma times Z1. Okay, so P2 equals to P1 plus gamma of the height difference at point 1 and point 2. So P2 equals to 310,342 plus the gamma, which is 0.85 times 9810 times the difference of the height, which is 0 at point 8 minus 2 meters at point 2. So the P2 is equals to 2938680 and the F2 is equals to the pressure at point 2 times the area at point 2, which gives you 293,680 times 1/4 pi of the diameter, which is 10 centimeter, 0.5 meter squared. So F2 gonna be 2310 Newton. Now let's look at 3.37. It's asking what is the pressure at the center of pipe B. So we're going to find the pressure here, PB. And looking at the problem here, we have PB and we have 50 centimeter of liquid with gamma of 10 kilonewton per square meter and 10 centimeter of another liquid with gamma of 20 kilonewton per meter cubed. And it also go to the other side, then it connects to the air. So let's assume here we have pressure at point A. This will be equals to 0 because it opens to the air. And looking at the pipe, right side of the pipe, we have a slope which is 3 to 4. So the longest edge of the triangle, small triangle here, is 5, and the length at the right part of the pipe is 50 centimeter. So the height of the pipe here is 30 centimeter. So now we're gonna write down the equation for the pressure at point B. So the pressure at point B plus the gamma, let's say gamma 1 here and gamma 2 here, gamma 1 times 50 centimeter plus gamma 2 times 10 centimeter will equals to gamma 2 times 30 centimeter plus the pressure at point A. Okay. So PB plus gamma 1, which is 10,000 Newton per meter cubed times 0.5 meter plus gamma 2 is 20,000 Newton per cubic meter times 0.1 meter equals to 20,000 Newton per meter cubed times 0.3 meter, and PA is 0 here. So the PB plus 5,000 Pascal plus 2,000 Pascal equals to 6,000 Pascal here. So PB here is negative 1,000 Pascal, which is minus 1 kPa. For the last problem, 3.43, we have a temperature in 10 degrees Celsius. We have water here, mercury here, and oil as well. So first we're gonna find the specific gravity of all three liquids. So the specific gravity of water and 10 degrees Celsius is 9810 Newton per meter cubed. Gamma of mercury is equals to 13.6 gamma of water. So it's gonna be 133,000 Newton per cubic meter, and the gamma of oil is 0.8 times gamma of water, which will be 7848 Newton per cubic meter. Now let's look at the height of the liquids here. So we're gonna start at point B with pressure PB here. We go down, the pressure will increase for 90 centimeter of water, then like 60 centimeter of mercury here. And this pressure will equals to the pressure at here. Then we go up here, and this pressure will equals to the pressure here, and then we go down to the point A here. So PB plus 90 centimeter of gamma water plus 60 centimeter of gamma mercury. We have another centimeter, but that was in oil. Sorry, it should be not minus because we are going up. Minus 30 centimeter of gamma oil. Then it goes to here. Okay. Then it's another 150 centimeter of gamma oil. Now we need to go down to point A. So we need to press that 150 centimeter of gamma water. So, and equals the pressure at point A. So now we move around a little bit for this equation. So your PA gonna equals to PB plus 0.9 meter times the gamma of water, 810 Newton, plus 0.6 meter times 3,000 Newton per meter cube, minus 1.8 meter times the gamma oil, which is 7848 Newton per meter, and plus 1.5 meter times the gamma water. Which your PA will be 89.2 kilopascal.